back to the Tin Barn. I'm Pragmatic Lee, and this week we got another little tool making project we're going to try to get completed today. I'm going to be using another piece of this old 2x2 rusty wagon axle that I salvaged a couple years ago. It's getting kind of short now, but we're going to be using a piece about 2 1/4 off of this. What I'm going to do is try to make some hold down clamps for this little vise. Now I bought this vise right after I got my surface grinder and been using it only on the surface grinder. And in the last week or so, on one of the Facebook groups I'm on, one of the machining Facebook groups, a couple guys or several guys got in a pissing contest over a fellow showing a picture of using a vise like this on a mill. I never thought twice about it. I've seen a lot of guys use these on the mills, but there was some dude that says he's got 40 years experience of tool and die making, and you can't use that vise on a mill, it's too much torque. The only thing that'll work on a mill is a Kurt vise. You know what I'm talking about, the guys that hide behind the keyboard. But it got me to thinking about, I don't have a way to hold this on my mill should I want to use it on the mill. And I have absolutely no problem whatsoever using this on the mill. I'm not going to be taking 200,000 depth cuts at the time unless it's a roughing in mill. The claim was that these ToolMakers vices just can't handle the torque that's applied on the mill. Well, like I say, I've seen many guys on YouTube use these vices regularly on their mill. So what I'm going to do today is, first thing I'm going to do is cut a piece of this off and get rid of all this rust. You've seen me work with this material several times in the past, so I'm not going to bore you with that. I'm going to get it cleaned up, and then we're going to meet back over at the mill and we're going to start cutting them out. And what I hope to do is make 4 of these clamps and make them in one piece and then saw them into the 4 pieces. So I'll get this cleaned up and we'll meet back over on the mill. All right, I got the piece milled now, got it square. One side, I didn't try to mill deep enough to get the pits out of it. A lot's going to be cut out of this anyhow. But before we start on the mill, I'm going to go ahead on over here to the surface grinder and set up and just grind it enough to take these end mill marks off of it, tracks off. Just trying to find it close now. And again, I'm not trying to put a super fine finish on this. All I'm wanting to do is take it down enough to clean the mill tracks off. Take several passes. And that found the high spot. That's what I was looking for. Based on the way this has started grinding, I'm comfortable in saying my mill is probably about a couple thousandths out of tram in about a 3-inch span. Either that or there was some a burr on that edge there. I'm only stepping down a thousandths at the time. All right, I've made a couple more passes and I'm down to where it's cleaned up across there now. But I'm going to start trying to put a little bit of a finish on there. I had been stepping down up on the fine feed up here 1,000ths at the time, and step over on the Z 100,000ths. What I'm going to do now, I'm going to take 1, 2, 3, 4 tenths, 4/10 of a thousandths, and I'm only going to step over 50,000ths at the time now. We're going to put a little coolant on there. pass right here is just to clean up the tracks from the wheel of stepping over 100 thousandths at the time. Only taking 4/10 of a thousandths cut now. Now for the final pass on there, I'm going to step down 2/10. 2/10 of a thousandths. And I'm going to step over only 20 thousandths at the time here. That final pass with only 2/10 there is basically a spark out pass. Now I think there's probably two things keeping me from getting what some would call a perfect finish on there. I can still see the lines just a little bit in comparison to the end mill. But I think there's probably two things that's keeping me from getting an absolutely perfect, I hate to use the term perfect, but a finish, professional finish, we'll call it that. And number one, I'm sitting on a wood floor. And every time, it doesn't matter if I use the power feed on here or if I do it by hand, when I make that transition, the surface grinder rocks just a little bit. And that's on this wood floor. That's one of the reasons I make a longer stroke on there than necessary with this power feed, is to give the surface grinder time to settle back down after it makes that transition. The second thing is, I can dress my wheels. I've got a wheel dresser here, but I don't have a way to balance them yet. And I believe my wheels are a little bit out of balance. And I think that has more to do with getting that perfect sheen on there than the machine actually rocking, since it does settle down. But in any case, I'm going to go ahead and do the same thing to the other two more sides over here. The fourth side that's got these pits in it, all I'm going to do is worry about the edges on that, because the rest of this is going to be milled out. But I'll bring you back when we get done with that part. Okay, I've got all four sides now surface ground. This side right here, I didn't put a whole lot of attention into it. Again, this is going to be, majority of this is going to be milled out. Also did the ends. And while this is all one block, what I want to do is try to put a little chamfer on the surface with the surface grinder on each of the edges around here. So what I'm going to use is a 45-degree transfer block. And I'm also going to use a block at the end of the material just to help keep it from, or just another little bit of insurance to keep the piece from kicking out here. So what we're going to do is just come down until we touch again. I'm going to back off of there. And what I'm going to do is grind across this until I have what is pleasing to me as a chamfer on there. Then what I'll do is set the 0 on the dial up here. And I'll be able to come back to that same depth on each of the four sides. I'm going to take 2/1000ths each time here. I suspect, based on doing this on other material, that about 40/1000ths is what I'm looking for here. I'm not even keeping up with it right now. I think this is 12. All right, I think that's a good looking chamfer. I wasn't keeping up with it. I don't know whether y'all were or not, but I'll just simply bring the ring over here where it reads 0. And I'll raise I'll raise it up probably about a half a revolution here just to know that it's out of the way. Okay. And again, what I want to do now is just keep working down until I come back to my 0 on the ring. So that's going to be about, this ring is 50 thousandths. I'm at about 47 now, just touching. So it's approximately 40 thousandths that I went down. And these first little cuts on here, I can go ahead and drop 3 thousandths at the time. All right, this should be the final pass. Now I'll continue that for the other 2 edges. I'll bring you back when I get ready to do the end. What that wound up being on the dial up here was 45 thousandths. So when I do the ends, I'll have to reset my 0, but I know where to start from. Now I've got the 4 edges done on the long axis, and I've got it set on the end now, and there's a lot sticking out here, so I think what I'm going to do, I think I'll take a second transfer block, set flat on the mag chuck with one of them, and then turn the other one up as such. And that should give plenty of force, should give resistance to the force going in that direction. So what I'm going to do now is touch off, just gradually bringing it down with the fine feed. All right, we're touching there. I'll set 0 on my dial and come down 45 thousandths. All right, this is the final pass here. And I'll continue to do that for the other 3 edges on this end, turn it around and do the same thing on the other end. I've got all the edges I can chamfer on the surface grinder done at this time. When I saw this into 4 pieces, of course I'll have some more to do, but this took care of the majority of them while it was all one block. Now what I want to do is use my height gauge and try to get an idea of or get a measurement on what the finished height is. And that is I'll have to lock it down and pick it up where I can see it. 2.491. Now what the saw that I'll be using to slit this with is 90 thousandths. So I'm going to forget that 1 thousandths there, 2.49. 90 thousandths, that's 2.4. Divide that by 2 is 1.2. Divide that by 2 is 0.6. So the holes are going to be the first thing that I drill. So let's see if I can get this set up on 0.6. I think my thinking is correct here. Alright, as I said before, this place where I didn't completely clean it up is going to be milled out. So the holes will go through, the bolt holes will go through the sides opposite of that. Alright, so from the ends, the bolt should be at the 0.6. Hope you can see what I was doing there. I was just simply using a carbide tip on this height gauge to mark that from each end. Now our finished width come out to be 1.873. If I divide that by 2, that would be 936. Double check that. 1.873 divided by 2, 9365. Okay. Double check that. 0.936. So we have just simply 2 holes to drill through this top right here, which will be at halfway. All right, as I drill through here, I'll have top and 2 pieces at the bottom. So I'm going to get set up on the mill to drill these 2 holes. I'll drill them, counterbore this side, flip it over, counterbore the other side. Got the workpiece in the mill vise now, and what I'm going to do is use the wiggler to locate the first hole. Okay, I'm going to set my zero out my DRO right there on that spot in case I need to come back to it. But I'll lock the table down. I'll do this 1 hole at a time. And my table mounting bolts, clamping bolts, are 3/8. So I'm going to use a 3/8 drill. Drill all the way through. All right, give me just a moment to go find my 3/8 counterbore. All right, I'll zero out the DRO and should go down 375 thousandths. All right, remember I set the DRO to 0, so I should be able to come over here where I can test this. And that's good. All right, so now we'll take the wiggler, find the second hole, drill and counterbore it. I'll bring you back when we turn over, and then we're going to locate those holes and counterbore them on the other side. All right, I've got the piece flipped over now, and all I'm going to do to line that up is just use the bit itself, the counterbore itself. Zero out at that point. Excuse my head, arm, and everything else. Okay, now it's time to lay out for the cuts the milling we're going to do in here to take that out. So I'll go back over to the workbench, get that set up, and then we'll come back and start doing some heavy milling. Okay, I've got a few layout lines on there now. Not that I'm going to use them a whole lot, but those were just sanity check marks. What we have, I've got the piece turned in there sideways now. As you can see, the bolt holes that we drilled are going through on the y-axis. So it's turned in here this way now. We're going to take out all this part that's graded right here. There'll be 3/8 left over here. This is the lip or the toe that will actually hook inside the slots in the vise. This is the end that will actually set on the table. So we're going to come in 3/4 of an inch from the sides and then 3/4 inch down. Do that both sides, clean that out. And to do that, I'm just going to use the paper method to find the edge. This is a 7/16 rough and end mill, and I really don't want to be changing out between the edge finder, which is a 3/8, and this. So what I'm doing right here, finding that edge with the paper will be plenty sufficient. Yeah, I need to remember which way my mill is turning. All right. We'll zero out the x-axis right there. I'm sorry, the y-axis. Now this is a 7/16 end mill, so that's 0.4375. That should have this outside edge even with the edge of the end mill. Now I'll zero out again and go in 375 and see how close that looks to my sanity mark. All right, should be right on there. So I'll lock the table down, zero the DRO, and this is a rough and end mill, so I should be able to take that full 375 thousandths depth. All right, let's back up and take about 250 at the time. All right, that's better. I got the feed slowed down now. Now we can go down remainder to 375. All right, the center trough is milled out now. I've got the end mill located on the center. I've located the center on the y-axis of our workpiece. And I'm going to take this out now down to about another inch in there. And then we'll take a look at it and see what we think. And I'm going to take about 200 thousandths at a time. All right, that's got the 1 inch gap in there. But I think what I want to do is step over, I don't know, I'm going to start with 50 thousandths. We're going to come back up to a 1/2 inch here. Now I'm going to step on each side of 0 50 thousandths. I'll see what that looks like on this end down here. All right, I think I'll go another 25. All right, now we'll go 75 thousandths on the other side of 0. Now we'll come back down to our 1-inch depth. Make another pass on each side. All right, I think we've got the heavy milling done. I do like that coolant. End mill just as cool as it can be there. All right, need to deburr this. Need to look at it one more time, be sure before I take it out. Mr. Pete says you can never get it back in the same place. This down here will be what sets on the mill table. This will be the toe that goes into the slots on the vise. So I think after I deburr it a little bit, we're be ready to put a slit in here. All right, I think we're ready to use a slitting saw now and slit it along this axis right here to give us two of our 4 clamps on each side. I've got some tall parallels in here now to be sure this is seated in there real good, because I've got to give clearance for the saw on the vise. Now I've got some marks on there. Again, they're just sanity check marks that are spaced from the edge so that the 90 thousandths, which is the thickness of the blade, is centered on there. What I want to do, though, is take an actual measurement with the DRO. And what I'm going to do is measure from these parallels, which is the same as the bottom, the distance between that and the top of a workpiece, and then divide in half. So there's touching off on the parallels. I will zero there. 1.897. 1.897 divided by 2, 9485. 948. I think that's close enough. Now we'll check it against my sanity marks. Looks right on the money. Let's see if I can get it. It may be just a little high. There's some spring in that blade when you're doing measurements like that. So in this case, I practically check. I trust my sanity marks more so than I do the spring on the saw blade. So we'll lock that down. I'm just going to, let's see, I need to slow way down though. All right, this is a brand new Niagara slitting saw. First Niagara I've had. So let's see how that does. Just a little deeper there. Slow the feed way down. Very pleased with the saw, slitting saw. Got a little burr there where it fell over before it finished cutting. I think that's probably within a couple thousandths right there of being the same height. All right, I'm going to deburr these. Then we're ready to stand them up on the end and slice them in two to make our final 4. All right, we got our pieces sawed apart, and off camera, I set these back in the mill as such and milled this surface, this one, and this one across both of them at one time to be absolutely certain that they were the same height. And the only reason I did that, they don't have to be that close, but I did that when I get ready to saw these in half. I want to put them in the mill vise again at the same time. But when we split these two pieces at this point, that exposed two more edges on each one that we can put our chamfer on. So I'm going to do that on surface grinder again using the magnetic transfer block. And when I get this set up, I'll bring you in a little bit closer so you can see for certain what I'm doing here. Okay, what I've done is set a 45-degree block against the fence back here at the back. Got it centered on the chuck. And again, these are not magnetic blocks. They are not magnetic. They are magnetic transfer. So got that on there. Now we'll set our workpiece on. And the forces are going to be pushing that way. So I'll just take another one of these transfer blocks, just as a little added security there, to make sure I've got all the help I can in holding that piece from shooting out in that direction. So what we're going to do is touch off here. All right, that's just beginning to touch. So as before, I'll zero out the ring on my down feed. And we're going to take this down about 45 thousandths, just like we did before. All right, here's our final cut. So what we did was just take this edge right here. Now I want to do the same thing to this outside edge over here. So push it up against my block. Okay, we got all the edges done we can do at this point now. So we've got this edge and this one. Once we get it sliced in two, we'll have a couple more edges to do over there. I'm going to do the same thing to the other half, then I'll bring you back when we get ready to go to the slitting saw on the mill. I'm back over at the mill now, and I've got the slitting saw back in. Got the two pieces stood on end on top of a parallel. Got the center located. Now we're going to slice these in and make 4 pieces now. We should be able to go to full depth. Let's be sure everything's locked down. All right, I don't think we're going to be able to go to full depth. Let's start right there. Okay, so just to clarify, the saw would have cut that full depth without issue. The spindle would have hit our piece though if we hadn't made the cut shallower. So now we'll just go around to the back side, and just like milling, we're going conventional cut here. Keeping our same height. Okay, we've got our 4 pieces made now, all 4 of our clamps. What I will need to do is go back over to the, let me get this in focus here. Go back over to the surface grinder and clean this edge off now, or chamfer this edge. It's really the only one that's left. This edge on each of the 4 pieces. Oh, I'm sorry, and this end here as well. So I'm going to do that off camera, and then we'll go back to the workbench and recap this video. All right, I think we're about ready to conclude this project. As I said at the beginning of the project, I don't know that I'll need this vise on the mill, but if I do, if I find a use for it on the mill, first off, I've got clamps now that I can mount it on the mill, and I'd have absolutely no problem using this type vise on the mill. I've made 4 of these clamps based on the size of my mill table and the size of this vise. I don't think I would ever be able to get but 2 at a time on there, maybe 2 on the sides, 1 on each side, or 1 on each end, just according to how I set it up. But it was just as easy to make 4 of them as it was 2, and they've got nice chamfered edges all the way around on all the exposed surfaces. So I'm pleased with the way these turned out. Hope you got a little bit out of this video, and we'll see you on the next one.